時間で始まりましょう。はい、皆さんこんにちは。オープンソース Kubernetes の最新情報へようこそ。Welcome to What's New in Open Source Kubernetes. 私はフィールズ・カズリンと申します。はじめまして。普段は Google クラウドでクラウドランタイムの Developer Relations の担当をします。また、CNCF アンバサダーや Google Kubernetes ポッドキャストのホストも務めており、SIG コントリビューターエクスペリエンスでは共同議長をしています。このプレゼンテーションを英語で日本語でもできますけど、どっちの方がいいかなと質問を聞きたいですから、手でI can do this in English or in Japanese. The slides will be in English. But 悪い日本語での方が欲しいAnd who would prefer it in English? 英語の方。All right, from here I'll switch to English then. Today I'll be covering a few new things in Kubernetes that I think are particularly important. These are things that show the direction of the project and enable exciting new use cases. I've learned these both from my work in the open source community over many years, and also from interviewing release leads and engineers developing these features on the Kubernetes podcast from Google. And I want to mention that sidecars is a particularly long section, so I put it at the end, and if we have time, we'll go through that one. If I had spoken in Japanese, it would have been in English anyway. So we'll see if we have time at that point. Otherwise, I might go quickly through that one. But to talk about cool new things in Kubernetes, it's important to first understand how feature releases work in Kubernetes. There are 3 stages of a feature release, and they indicate progressive levels of stability. When a feature is first released in Kubernetes, it's usually released as alpha. This means that the feature is new and hasn't seen much real-world use yet, so it's not enabled by default. The engineers developing it think it's ready for some real-world usage and feedback, so you, as a user, can choose to try out that new alpha feature, but you don't have to. So releasing things first as alpha lowers the risk for users. Once the engineers have hopefully gotten a little bit of feedback from having the alpha version out in the field, the next step is to release that feature in beta, which means it will be enabled by default on Kubernetes clusters of that release version or higher. For example, in-place pod resize, which we'll talk about later, was released as beta in 1.33. Even though they're on by default, beta versions of features are intended to be removed at some point in the future, so you should still take dependencies on them very carefully. Note that at this stage, there are actually 2 versions of the feature available in Kubernetes. The alpha version, which isn't enabled by default, is still there, and some users may still be using it. And then there's the beta version, which is on by default. So at this point, you could have users potentially using either the alpha or beta version, or both of them. And the big moment for a feature release is, of course, when it hits stable, or generally available, which we also call GA. This means that the feature is enabled by default, and Kubernetes is making a promise that that feature is going to continue to exist and be available through the current major version. So Kubernetes releases like 1.33, the 1 is the major version, and the 33 is the minor version. And there are no plans for a Kubernetes 2.0. So if a feature is stable, you can pretty much expect that it's going to be around for a while. So a stable version of a feature will stick around, but I mentioned that beta versions are intended to be removed. And we still have that alpha version of the feature hanging out too, probably. And people could be using alpha and or beta versions of that feature, even after the stable version is released. We can't really force people to migrate off the version that they have been using, so it's up to users to test and adopt the stable version once it's available as the feature stability progresses. But at some point, those older versions of the feature will need to be removed to keep the Kubernetes code base more manageable. Removing a feature happens in 2 stages. First, a feature becomes deprecated. This is a warning that the feature will be removed soon. When the feature is actually no longer available in Kubernetes, it has been removed. Most of the deprecations and removals that you see in releases are generally alpha versions of more mature features that are just being cleaned up, since a better, newer, more stable version of that feature is probably available in the code base. Now, let's move on to our first feature. This is really not a feature, but a pattern or a trend that has been happening across Kubernetes releases. The problem is that there's a lot of code in Kubernetes, or at least there traditionally has been, a lot of code in Kubernetes that is very vendor-specific, which most users don't need. If you're running your workloads in an AWS hosted cluster, you don't need Kubernetes code that's meant for Google Cloud or Azure. So that's a lot of excess code if we have a lot of vendor code in Kubernetes. Storage vendor and cloud provider code, in particular, were originally added to Kubernetes directly. That created a lot of code that users didn't need, and it also created a lot of headaches in the release cycle because we had to work with the storage vendors or the cloud vendors to say, hey, we do 3 releases a year, the next release is coming up, do you want new stuff in it? And you had to coordinate all the releases, and it was terrible. The solution to this problem is to remove it. Just remove the extra code. Kubernetes is extensible. All that vendor-specific stuff can be added as a custom resource definition. So the new pattern is for vendors to own their own code, and engineers who need it can install it on their clusters using custom resource definitions. This pattern of removing vendor code in favor of custom resource definitions has had 2 major moments. First, storage plugins were removed from Kubernetes starting in 2018 and going through Kubernetes 1.25 in 2022. Removing cloud provider-specific code took longer, both to get started and to finish. And cloud provider plugins started to be removed with Kubernetes 1.26 in 2022, and they only just finished up with 1.31 in 2024. That 2024 change removed over 1 million lines of code from Kubernetes. Can we get a round of applause for keeping Kubernetes sustainable and extensible? Love that one. Next, we're going to talk about dynamic resource allocation. So this is a huge and very new feature in Kubernetes. DRA was proposed in 2022 with a major redesign in 2024. So it's a very different thing. If you heard about it prior to 2024, it is a very different thing now. It's gone through a pretty quick development cycle with its stable launch planned for the next release, 1.34, which is coming up in August. The problem is that Kubernetes was designed primarily for stateless web app style workloads, which don't care much about what kind of processor they're using. AI workloads are different. Running AI workloads requires tight control of the underlying hardware accelerator resources, both in terms of how the app uses those resources and in terms of cost optimization. DRA, or dynamic resource allocation, enables flexible and efficient use of hardware accelerators like GPUs. It allows workload-specific accelerator sharing for cost optimization, so one workload can share multiple workloads can share one GPU. It also standardizes managing complex types of hardware and complex assortments of hardware. You may have many different kinds of hardware in your clusters. And it also supports declarative device allocation. So you can use the standard declarative model in Kubernetes now to more granularly define what kinds of hardware resources your workloads need. Not something Kubernetes had originally, since it was geared toward web applications, but they've added it with DRA. And then it improves, of course, GPU obtainability and optimizes node availability. And that's all I have to say about dynamic resource allocation. If you want to learn more about it, there was another talk here that dove deeper into it. Also, feel free to ask questions. But the next feature I want to talk about is Gateway API. This is also not a feature. It's rather a standard produced by open source Kubernetes contributors, and it was originally proposed in 2019 and had its 1.0 release in 2023. Networking is a very vendor-specific kind of thing. Whatever environment you're running within, the networking is, when you get down to it, the cables between the machines and how the machines talk to each other. So it depends very much on the environment that you're working in. So while Kubernetes users need a lot of the same things from their networking, the actual way that's achieved is very different in different environments. This sounds just like that out-of-tree vendor code problem we just talked about, doesn't it? And do you remember what the solution to that problem was? Oh yeah, that's true. But in this case, it's custom resource definitions. It would also be remove it if we actually had a lot of code in this area in there. But in the case of the out-of-tree thing that we were talking about, the new solution for those types of use cases is to implement them using custom resource definitions. So we see the same thing here. And so the Kubernetes Gateway API is a standard that is defined by the Kubernetes open source community, the contributors who are contributing to Kubernetes all the time and know it really well. And it defines the APIs that Kubernetes users need to manage traffic for their applications. Then vendors implement that Gateway API standard to enable more robust, modern traffic management for Kubernetes users in their environments. So the idea here is that you have a unified API where you, as the Kubernetes user, can set up your ingress and your traffic management all in the same way with the same API calls, but vendors will implement them with their specific networking configurations in mind. And that's all I have for Gateway API, so I'm moving right along into in-place pod resize. This is another feature that is especially useful for AI workloads, but it's been a problem since long before the current AI hype cycle. And it is in-place pod resize. This feature was proposed 6 years ago in 2019, and it was released in alpha in 2023. And it's now in beta as of April, I believe. Kubernetes has this thing called vertical pod autoscaler. Any vertical pod autoscaler users? It's pretty rare, honestly, to find them. Oh, there's quite a few here, though. And the vertical pod autoscaler can change your pod's requests and limits automatically based on defined metrics that can change over time. So it can basically be constantly monitoring your workloads, and as the amount of traffic to your workloads changes, it can change the resource requests and limits for those pods. But if you set it to the mode where it does that automatically, there's also a mode where it just tells you what you should set, which is what most people use. But if you're trying to use it in actual auto-scaling mode, where it automatically changes your workloads, it will restart the pod every time it changes them. Or at least it used to. In-place pod resize allows you to modify the CPU and memory resources for a running pod without restarting it. So this is a pretty exciting feature, especially for AI workloads, which are very spiky in their usage of resources. And also, other use cases I've heard have been Java and Kafka, interestingly. All right, we're definitely going to get to sidecars, I think. Yes, we're definitely going to get to sidecars. So this is the last one I have before sidecars, and it is registry.k8s.io. This also isn't a Kubernetes feature, but it is a change to the way that Kubernetes is deployed. The problem is whenever a new Kubernetes cluster is born, the images that define it have to be pulled from somewhere. Have you ever seen egress charges for pulling data out of a cloud provider? They're high. So every time a Kubernetes cluster is born, the Kubernetes open source project, aka the CNCF, thank you for the money, pays the bill for the image pulls. The community re-implemented the registry where it hosts those images for Kubernetes so that they're available in multiple cloud providers. So if the registry gets a request from a specific cloud provider, it now serves that request from within the same cloud provider so that we avoid those egress charges. So if you ever deploy Kubernetes itself, like you're not using a vendor solution like GKE or AKS or whatever, but you're deploying your own Kubernetes, make sure you're pulling them from registry.k8s.io. The other one doesn't exist anymore, so you're probably not pulling from that, but but make sure you are, because it saves us a lot of money. Thank you. Now, I am going to go into sidecars. I really enjoyed putting together this explanation. I don't know if you've heard of sidecars before, but we're going to dive into them. So this feature has been in the making for 7 years. It was first proposed in 2018, and it was released in alpha and also beta in 2023, early in the year versus late in the year. And it just reached stable in April of 2025. Yay! And by the way, I drew this artwork myself, not AI. What is a sidecar, and why is it so great? So sidecar containers extend and enhance the main container. They take existing containers and make them better. Let me explain what that means. In your Kubernetes cluster, you have pods. A pod is the Kubernetes abstraction that allows it to manage your containerized application. A pod can be made of one or more containers. This is something that folks often forget in the early days of learning Kubernetes. So let's say someone is trying to use your application. You have some traffic coming into your cluster, trying to reach the app that lives inside that pod. With a sidecar, you can intercept that traffic. There are lots of reasons you might want to do that. For example, maybe you want to enforce MTLS security, or maybe you want to do some extra logging without actually implementing that into the application code. The sidecar container can do this because every container within a Kubernetes pod shares the same resources. They share the same IP address, they share the same storage space, they share all the same stuff. And so the sidecar can interact with anything that the main container could possibly interact with. The sidecar can then allow that traffic to connect to the main application within your pod, or deny it, depending on what you have it doing. So from your perspective, a sidecar is a container that sits right next to your main application container and can allow you to do cool things that improve the functioning of your primary application. But Kubernetes' perspective is a little bit different. What rules does a sidecar need to follow from Kubernetes' perspective? What makes a sidecar container special? What does a container need in order to be a sidecar? These are the questions. So from Kubernetes' perspective, a sidecar is just a container that starts before the main application container in a pod, and which continues to run throughout the entire life of the pod. There are 3 basic traits that we need from Kubernetes' perspective in order to implement sidecars. 1, it shares a pod with the main container. 2, it starts before the main container. And 3, it should live as long as the main container. There's a couple ways we might achieve this in Kubernetes. For one, you could just deploy the pod with 2 containers in it. But Kubernetes doesn't make any guarantees about which container will start first. So that gets rid of one of our 3 requirements, so that's not ideal. How about if we create a new Kubernetes object called a sidecar container? This actually doesn't really make sense with the way that Kubernetes is implemented, because a pod is the smallest unit that Kubernetes manages. This is also something that newcomers often get tripped up on, because Kubernetes is a container orchestrator, so it works with containers, right? No, Kubernetes doesn't care about containers. Kubernetes cares about pods. And sidecars are a specific type of container, which is smaller than a pod. So Kubernetes can't really manage something that granular. So it kind of breaks the fundamental design of Kubernetes, so we can't really make just like a sidecar object. Lots of problems with it. But Kubernetes does have an existing feature for managing a special type of container within a pod. It's called init containers. Init containers share a pod with the main container. We can also guarantee that they start before the main container. They just weren't designed to live as long as the main container. They were designed to do some stuff for it and then go away once they've helped the main application start up. But it certainly seems like a promising place to start. And lo and behold, the Kubernetes community implemented a way to make an init container live as long as the main container. Ta-da! It's a native implementation of sidecars. I think that level of enthusiasm was correct. So that's all I have for you today. I just wanted to give you an overview of a bunch of new features that are in Kubernetes that I'm particularly excited about. And if you're interested in these new features and how they're designed and all of the interesting problems we meet along the way, join us as a contributor. Thank you all for your time and attention today. So if there are any questions, I have time. Do we have a mic? They're grabbing the mic.
Thank you for the interesting session. I have a question about the Gateway API. So I know that there is no plan to be removed about the ingress because it is the stable resource. But does the Kubernetes community have a plan to recommend to migrate from ingress to Gateway API?
Would you like to contribute to Kubernetes today? That is a huge thing that the Kubernetes community is discussing. Gateway API has been generally available since 2023, I think I said now. So it's like 2 years, over a year easily at least. Ooh, that's more than that. Anyway. And they are having a lot of trouble with adoption exactly because of the reason that you stated, because Kubernetes has an ingress object. And it's like, if you want to manage the traffic to your pods, if you're brand new to Kubernetes at least, you'll probably just use the ingress object. And then once you figure out that it doesn't do what you wanted to do at all, you'll use something else. And part of the challenge with Gateway API is also we need more implementations by vendors in order to show people that it's a standard that is implemented widely across vendors. So that then, one thing I was talking about in my previous talk, I did a talk about multi-cluster, and I talked about some APIs from the open source community there. Same pattern, out of tree stuff. And so the challenge there is the next level up. Too. Like once you have the vendor solutions, the vendor implementations of the API, they should all use the same API no matter what vendor you're using. But then you'll need the next level up to kind of manage across all of those. So there are some challenges with how we market it. And also, like you said, it's a stable feature. So it's not like we can get rid of it. So we're open to ideas.
Okay.
Thank you. Anyone else? All your Kubernetes open source questions answered. I also run new contributor orientation.
Thank you so much. Thank you so much for a great presentation. And I was curious about the sidecar's background. And my question is there any discussion about adding a sidecar field instead of utilizing the init container? Because I feel like setting a sidecar is kind of the more natural for someone who, like me, are familiar with the sidecar concept.
It's so anticlimactic, isn't it? When we're like, oh, we have this new sidecar thing. The number of people I got asking me questions about, oh, what is this new sidecar thing everyone's talking about, was very high. and then when I explained to them, it's just a field in init containers. It's very anticlimactic. But no, since the native sidecar feature is now going stable in August, that's certainly always going to be there. And as far as the technical considerations on the Kubernetes side, it fulfills everything that we need. It's more of a marketing problem, really, of like, users are not going to be able to find that. So here, now you know, at least, that exists. But kind of like with Gateway API, it's kind of a marketing problem.
Yeah, that's true. Thank you.
Any other questions? 日本語でも大丈夫ですよ。All right then, I think we've accomplished our purpose here, and I hope to see you around the event. Feel free to ping me on Kubernetes Slack anytime I'm around, and I run new contributor orientation. So I hope to see you in the community.